Hi everybody, today we're going to talk about scientific notation. What I really like about scientific notation is that it has a purpose. Scientific notation is a way to express very large or very small numbers, and we'll get into a few examples to show you why we would use it. As we start to use scientific notation, numbers are going to be written in the form a times 10 to the n, where this number a in absolute value is greater than or equal to 1 and less than 10. So we always want to make sure that this number a, and it doesn't matter if it's positive or negative, that's why we have the absolute value there, is at the smallest equal to 1 and at the largest is less than 10. When we're thinking large numbers, we're really thinking like powers of 10. So what you can see is I listed some powers of 10, like 10 to the 0 is 1. And 10 to the 1 is 10, and 10 squared is 100, 10 cubed is 1,000, 10 to the 4th is 10,000, 10 to the 5th is 100,000. As we continue on, I hope you see the pattern that the exponent n corresponds to the number of zeros and the expansion of the number. If we turn this around to talk about small numbers, then we have negative exponents. So 10 to the negative 1 is 0.1, 10 to the negative 2 is 0.01, 10 to the negative 3 is 0.001, 10 to the negative 4 is 0.0001, 10 to the negative 5 is 0.00001. That negative n corresponds to how many digits away we are from our decimal place. So let's practice writing scientific notation. I'm going to start with 3,600,000, and I'm going to write 3.6. So my number 3.6 has to be greater than or equal to 1, less than 10, and then I can count 1, 2, 3, 4, 5, 6. So this tells me this will be multiplied by 10 to the positive 6 exponent. This next number is 78,540,000,000. So when I go to write this, I write 7.854. So I want to keep all of the numbers I see that aren't zeros. So as we go, I'll keep explaining what that is, but I can see after the 4, I just have a bunch of trailing zeros, so those get to drop off. So I'm going to say times, and I'm going to count. You might find it easier to draw a line between my first number 7 and all of my other digits, and then count those. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 to the power 10. One more on this page, I have negative 120,400. Now I'm going to draw this line, which tells me where to start. So I have a negative 1.204. Now this time I did have a 0 trapped between two other non-zero numbers. I am going to include that 0 in my scientific notation. Then the other ones can drop off. So this, I'm looking for my power of 10. So after my line, I count 1, 2, 3, 4, 5. So this is 10 to the 5th. Let's try the same thing, but with small numbers. I am still going to draw the line between the first two numbers that I see, so my 4 and my 5, and I'm going to say this is equal to 4.5 times. And now this is going to be a negative exponent to show that I moved to the right. So I went 1, 2, 3, so this is negative 3. So as you're counting, count up to the line. That will really help you when you're converting from ordinary to scientific. So same thing here, I put this line here. So 1, 2, 3, 4, 5, 6, 7. So I have 1.21 times 10 to the negative 7, and this number was negative. Okay, one more. I have 0.00008, so I'm going to draw the line right after the 8. So I'm going to say this is 8.0407. So I use the zeros that are trapped between the other numbers, and I drop all the ones that are not trapped between other non-zero numbers. And then I'm going to count 1, 2, 3, 4, 5. So I'm going to say times 10 to the negative 5. Let's go the opposite direction. This time I gave you scientific, and I want to write this as an ordinary number. So here I have 518. So what I want is a total of 7 digits to the right of the 5. So here's 1, 2 already, 3, 4, 5, 6, 7. If you want to put your commas in as separators, if that helps you see this number as 51,800,000, then definitely put those in. Same thing here. The negative in front just tells me the number itself is negative, so I have negative 90125. What I want to make sure is I have 10 digits to the right of 0. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's 10 altogether. Every 3, I'm going to throw a comma to help you see this number. 90,125,000,000. Really big negative number. Hopefully that's not somebody's debt. Let's do a couple more, this time with the negative exponent. So this 4.8, 10 to the negative 5 says I want to start with a decimal, and I want to count 1, 2, 3, 4, and then that fifth number is going to be my 4, and then my 8. So I want this negative 5 to say 1, 2, 3, 4, 5 places is where my 4 goes. Same thing with the negative 5.32. I'm going to start negative. I put a 0.0, 0, and then 5 goes in the third spot for the negative 3, and then I say 3, 2. So why do we use this? Well, let's look at some examples of things that we might use really big numbers for, like the distance from Earth to Mars. The distance between Earth and Mars changes as the planets move around their orbits. So at the closest point, they are 3.39 times 10 to the 7th miles apart. So let's talk about how we would write that in ordinary notation. So I'd have 339, and what we want to say is I need to have 7 digits after this beginning 3. So there's 1, 2, 3, 4, 5, 6, 7. So let's put our comma separators in there to say this is 33,900,000 miles between Earth and Mars at their closest. At their furthest point, they are 2.5 times 10 to the 8 miles apart. So let's write that in ordinary notation. So I have my 2, that's my first digit, and then my 5. Well, I want to have a total of 8 digits after the 2. So here's 1, 2, 3, 4, 5, 6, 7, 8. So now I have a total of 8. So 1, 2, 3, a comma, 1, 2, 3, a comma. So at their farthest, they're 250 million miles apart. Let's think small. So small, I think, a grain of rice. So this says the weight of a grain of rice is 0.000142857 pounds. And part of that is just the unit that we're using here. Pounds to measure rice is a really big measurement. Maybe we want to go to grams or ounces or something to talk about instead. But we have pounds, so let's go with that. So how would we write this in scientific notation? Well, we would draw a line after the 1. We would write 1.42857 times 10, and I'm going to count up to this line. So I went 1, 2, 3, 4. This is to the negative 4, and it is pounds. Another small unit, let's look at the average width of a human eyelash is 0.07 millimeters. How would we write that in scientific notation? So this one's pretty small, and notice there's no number after 7, so I'm just going to write a 7, and I'm going to say times 10, and then look, I only went 1, 2 over, right? This line would be here, so I would say negative 2. If we start to look at operations with scientific notation, it's important that we write our answer also in scientific notation. Let's look at what that looks like. So say I had this 3.2 times 10 to the 4th, and I want to multiply by 5.8 times 10 to the 9th. I want to kind of group this together. So let's say I do 3.2, and we'll multiply that by 5.8. And then we're going to group the exponent part together, 10 to the 4th and 10 to the 9th. So start with 3.2 times 5.8. This gives me 18.56. 10 to the 4th times 10 to the 9th, when I multiply the same base, I'm going to add the exponent. So 14 plus 9 is 13. Well, here's a problem. This 18.56 is not between 1 and 10, so I need to rewrite that. So I'm going to call this 1.856 times 10. So now this 10 to the 1 gets to be combined with this 10 to the 13. So I have 1.856 times 10 to the 14th power. So it's important that you finish with a number that matches our scientific notation. Let's also try that with division. So if I have 1.75 times 10 to the 16, and I divide by 2.5 times 10 to the 24, I do 1.75 divided by 2.5, and I do 10 to the 16 divided by 10 to the 24. 1.75 divided by 2.5 is 0.7. 10 to the 16 divided by 10 to the 24, I need to do 16 minus 24, which is negative 8. So again, I need to make sure my answer is written in scientific notation. So 0.7, that's not from 1 to 10. So I want to write it as 7 times 10 to the negative 1. Look, I just go 1 over when I'm writing. Then I'm multiplying that by 10 to the negative 8. So I'm going to have 7. I'm multiplying 10 to the negative 1 times 10 to the negative 8, which says I'm going to combine those two numbers, and that will give me 10 to the negative 9. So I hope that was a good refresher for scientific notation. I think the more you do it, you really get better at it. I hope you can also see that there's a lot of reasons that we are going to look at this multiple times throughout the semester.